Okay, so let's recap last week's content. So the first thing was addition, which we all know obviously, but we learned about the two main properties of addition, which is first one is first property is the commutative property, right? Which means you can switch the additions around, which you guys already know about. We just started using it in a more clever way. So a plus b is the same as, switch them around, it's the same as b plus a, right? It's commutative property. So for example, 2 plus 3 is the same as 3 plus 2. But obviously we use this in more complicated problems than this, but just the basic property. Second thing is the associative property, which basically says even if you don't switch in that order. First of all, do you know what brackets mean in math when you see brackets? Yeah. Ah, yes, please. Okay, what do brackets mean when you see it in maths? Oh wait, I didn't give you the handout. Do you have last week's handout? Yeah, we're going to continue on from that to begin with. But I'll also upload the homework solutions tonight, and also the I haven't got a copy of the homework printed today, but I'll upload it tonight as well for this week's homework. Okay. So the associative property, right? Which means, first of all, what do brackets mean? Anyone explain to me what brackets mean?
Like when it's like different, like properties, like division, addition, or just addition. So, like last week.
Yeah. But what about just brackets? Like, what about not this property? Sorry, just in bracket general. We see brackets in math. What does it mean?
You had to do it first.
Yeah. Right. Because first rule is left to right, but brackets override that rule. Right? Even if it's to the right, if you see in brackets, you go do that first. Right. But just for addition, when it's only addition, the associative property is saying you can ignore that rule. When it's just addition, all three additions, all two of them are additions, you can be like, oh, it doesn't matter which one you do first. You could do a plus b first, or you could do b plus c first. You could do this one first or this one first. It doesn't really matter. Right? So the associative property just means that they're equal regardless. So for example, if you do 2 plus 3 plus 4, right? If you do the 3 plus 4 first, it's the same, and you get 7 plus 2 equals 9. But the same as if you did 2 plus 3 first, plus 4. Right? If you do 2 plus 3 first, what do you get?
4.
Right? And then you add 4 to that, you end up with 9. That's the associative property. The second topic we learned. Right? And then we all went to multiplication. Multiplication, again, we do the same thing. So I'm not going to go over the associative distributive again. I'm just saying we learned that distributive and not distributive, that the commutative and the associative property both work for multiplication. Right, do you remember that from last week? No problems with those? All right, that's good. So I want to explain these two, but if you have any questions, let me know. But it's just the same as addition, where this is a times b times c equals a times b times c, and this one's basically saying a times b is b times a. You can switch them around multiplication and addition. So it just wants you to become comfortable moving multiplication and additions around. It's just these properties allow you to move them around comfortably, no problems. All right. Okay, now we'll go this week. So we started on it last week. Well, I'll go from the start again. So let's talk about this first. I'll wrap it up. Start from scratch, only a little bit. Okay. Let's go through this example first. So our goal is to find the total number of small squares in the following shape. Right? We're not gonna not just get the number, but just multiplication of it. So, for example, we can do it this way. We can just consider this red rectangle, right? What's the total number of squares in the red rectangle? 1, 2, 3. This 3 is, yeah. Oh, wait, we'll leave it as a multiplication. We'll leave it 3 times 7, right? So we'll just leave it as a multiplication. It is 21, yeah, that's good. But if you do the same thing for the blue squares, what do you get?
5 times 7.
Yeah, 5 times 7. Right, so then in that way, when we do it this way, total squares is 3 times 7 plus 5 times 7. But what if we just sort of went like, I don't care about the colors, let me just look at the whole shape. Then what's the total number of squares? What's this length here, the blue length? It's 3 plus 5.
8 times 7.
Yeah. I'm going to leave it a different way, but it's the same thing. 7 times 3 plus 5. Right? And since it doesn't matter which way I count it, am I going to get the same answer if I do it this way and this way? Yeah? Or no, different answers or same answer? Same answer, right? Because the number of squares doesn't change. So what that means is that 3 times 7 plus 5 times 7. Oops, I'll put 7 first because it will look nicer. 7 times 3 plus 7 times 5 is the same as 7 times 3 plus 5. That's what it's just saying, just for this thing, right? But even without but is there anything special about these numbers 3, 5, and 7? No, right? You can just do it with any numbers. You can do 5 times 8 plus 13 is the same as 5 times 8 plus 5 times 13. Do you think that's true as well? Like if I just do here, if I just be calculate like this, and I calculate like this, flip it to, and it should stay the same, right? Just because it works here for these numbers, but there's no reason why it shouldn't work for the other numbers as well, right? So let's take a look at an example without a picture. So let's compare the answer to part A with the answer to part B, sorry. And if they're the same, we can be reasonably comfortable that the property holds, right? Seen a picture of it as well. Okay, what's 3 plus 7 times 4? Let's do 3 plus 7 first.
10.
Yep, so it's 10 times 4, which is 40. Oh, 10 times 40, 10 times 4, which is 40. Right, but here, if you do the multiplications, remember BODMAS, you do the multiplications before the additions, right? So Sarah, 3 times 4 plus 7 times 4 is?
28.
Yep, very good. That's equal to 40. So the answer stayed the same. So it means when we have something like this, we can go either way. If we have something like this, we can go say that it's equal to this. If you don't want to do the multiplication separately, if you want to do only one multiplication, you can put it into brackets. Because we multiply by the same number 4 here, you can take out the 4 and put the 3 plus 7 separately. Right? It can be really powerful. But the idea is that this property will work with any 3 numbers. That means if I have A times B plus C, same as, what do you think this other side should equal? I can do this one first, so A times B, and I can do this one second, plus A times C. Oh, also, with letters, you're allowed to do this. When you multiplication, you can ignore the multiplication. So you can AB plus AC. You're allowed to do that, by the way. We'll see that more and more. Just getting used to this. So in letters, sometimes when it just says AB, it doesn't mean A is the 10th position, B is the units position. You're just saying A times B. All right. Okay. So we'll go to some problems with this now. But here's another example. So this is the general property, which is that A plus B times C equals A times B plus A times C. But also you can ignore the multiplication signs when it's just letters. You can't say 2 times 3 is 2, 3. That's obviously not correct, right? But when it's letters, you can ignore the multiplication sign like this, like I saw here. Okay. All right. So we'll go to a video. Okay, let me just go. Distributive. All right. So Ryan, let me know if the
Fastest
audio
home fiber
works.
to more Australians.
Be the same.
So Ryan,
And that's what the distributive
audio. Hey Ryan.
Yeah.
Can you hear the audio on the video?
Yeah.
We'll get started from the beginning again. So this is just like, any questions with this before we go to watch the video though, with the distributive property, or it makes sense? Please let me know before we start. Like even if you had a bit of doubt, hopefully this will clear it up. Let's watch this.
There's a special rule that combines multiplication and addition. We're going to find that rule by counting these little squares. Now there are a couple ways we can count these squares. We can count the squares over here, count squares over here, and then add the two. Or we can see that we can fit these two rectangles together nicely. Make a larger rectangle, and then we'll just count the little squares in the larger rectangle. So now let's go ahead and do both of these counts. This little rectangle over here has 2 columns. Each column has 3 squares. That's 2 times 3 little squares. Over here we have 5 columns, each with 3 little squares. That's 5 times 3. So the total number of little squares up here, we just add these two. Now coming down to the big rectangle, we know how many columns are here because we just pulled these 2 rectangles together. There's 2 plus 5 total columns there, and each one has 3 little squares. So that's 2 plus 5, that whole thing, times 3 little squares. Now, of course, we're counting the same group of little squares in both cases here. So these two totals have to be the same. And that's what the distributive property tells us. This expression equals that expression. Now, there's nothing special about 2, 3, and 5 here. We can do the same thing with any 3 numbers. And that's the distributive property. Instead of 2, 3, and 5, I just write this down with A, B, and C. The distributive property tells us that this is always true for any numbers A, B, and C. Now, of course, with multiplication, if you're multiplying 2 numbers, it doesn't matter what order you multiply the 2 numbers. So I can reverse this product and write it as C times A plus B, and reverse each of these 2 products.
What's that property he used to switch them, those two over? When he switched from A plus B times C to C times A plus B. One of the 2 properties we learned last week. When you switch the 2, it's called the subset C. Curve. Sure. That's all. Commutative property. Right? That's why it allows him to switch it around. A plus B times C is the same as C times A plus B. Because just this is one number, it's another number. Because multiplication, you can switch them around. Alright, okay.
So this is C times A, and this is C times B.
See, he doesn't put enough.
So I can write the distributive property either way. I can put the sum second, or I can put the sum first. And I can even have more terms in the sum. So for example, if I started with something like 4 times x plus y plus z, I can apply the distributive property to expand this, and we say expand when we multiply it out as 4x plus 4y plus 4z. And all I'm doing here is multiplying the 4 out here by each one of these terms. And that's what we do when we expand this product into this sum. Now if we go the other direction, if we start with 4x, 4y, 4z, we see that there's a 4 in each one of these terms. We can use the distributive property to write it back as this product. And when we do that, we say we factor out the 4 and write it as 4 times this sum here. Now, let's go ahead and put the distributive property to work with a problem. Now, if you see this, you think,
Look how tricky that looks, right? If you just try to do it by hand, it takes a long time, right? So they'll see how he's going to use the distributive property to make the problem really easy.
oh my goodness, it's going to take forever. Because, you got to do all these multiplications, and those aren't real easy multiplications. But then we see, hold on, there's a 93 in each one of these products. We can use the distributive property. We factor out the 93. And we write this as 93 times the sum. We pull out the factor of 93 from each one of these products, and we're left with 21 plus 9 plus 52 plus 19. And that's a lot easier to deal with. We can add these up in our head. 21 plus 9, that's 30. 52 plus 19 is 71. 30 plus 71, that's 101. So this is just 93 times 101. And this, well, you can see what the product is, but we can also just use the distributive property again. 93 times 100 plus 1. 93 times 100, that's 9300. 93 times 1 gives us 93. So 9300 plus 93, well, we know what that is. That's 93. 93. And we're done.
Does that make sense how why he did that? And look, he didn't just use it once, but he didn't just use it to bring into the brackets. He also expanded the brackets, splitting the 100, 1 into 100 plus 1. So he used it both ways. He put it into the brackets, but also expanded the brackets as well. So he used both distributive property both ways. All right, now we'll go through an example. Okay, let's go here. All right, before we go to the example, I want to ask you, is there a difference between a plus b times c and c times a plus b? Because we saw in the video. No, right? And why is that?
It's the same thing, it's just reversed.
Yeah, it's a commutative property, right? You switch the two around, it doesn't change anything. So the commutative property allows us to switch it. Switch the two. Right. Okay, so now how do we use this? How do we use this distributive property, right? So we saw it in the problem, we're going to talk about it more explicitly now. So first of all, we have a lot of multiplication going on. So we can put into one of, just make it like one multiplication, but if there's a common factor. So for example, I mean, there's only 2 here, but another example would have like 3, 4, 5 multiplications. Let's look at this one, right? It's only 2 multiplications in this one. But we can convert that 2 into 1 by noticing that there's a common factor of what? What's a common number in the 2 multiplications? In this example here.
It both has 50.
Yeah. And that's why you can use for the distributive property. Right? Because there's 15 common. You take out the 15. Right? And then you're left with this big number becomes just 4. This number becomes just 7. Instead of being 15 times 11. Which you can use in doing your head long multiplication. But if it's hard to do in here, you can do the distributive property again. You can split it up 15 into times 10 plus 1. Then you go 15 times 10 plus 15. So you can expand out using the distributive property as well. Because everyone knows how to multiply by 10, right? You just add a 0 to it. So we split it into harder multiplication to easy multiplications. That's what we're doing here. Or, like I showed here, it's not too complex, but something like this is pretty complicated. 21 times 53. What we can do is we can split into what? 21 times. How can we split this up to make it easier?
5 plus 50 plus 3.
Right? Because if we have 50, multiplying by 50 is really easy. It's just multiplying by 5, then you get a 0. So this, you do 21 times 50. It's 21 times 3. And 21 times 5 is what? 105, is it? 21 times 5. 5, 10. Yeah, 105. 105, add a 0, 1050 plus 63, which is just 1113, I think. 1113. Right? But then you can also use a cool like math tricks like here. So for example, what I'm going to do is, you guys can ask me, tell me any number to put here, any 2-digit number, and I'm going to tell you what it is immediately. Any 2-digit number, tell me to multiply by 101. Okay.
93.
9,393. Check on the calculator. Right? I'll show you how you can do it quickly. Right? So it seems cool, but it's actually pretty easy once you know what I'm doing. I can give you another one if you want. Any other number you want to do? Sure. All right. Okay, we'll do this one. You can give me a 3-digit number, you can multiply by this. Any 3-digit number. Smaller than 500, I prefer. If you go high, I'll try.
432.
432, 864. We can check. So, what do you think I'm doing here? Look. When you said we said 97 before.
93.
93. Yeah, we said 93 times 101. Well, all it is 93 times 100 plus 1. And 93 times 100 is just adding 2 zeros. That's 9,300. And then you add plus the 93. So I just got this. This 2 is the first 2 digits. The second 2 digits. I just added these together. Right, 93 times 1 is really easy. You're going to do it almost instantly in your head. And the other 93 is 93, 93. Right? And this one seems cooler, but it's actually, this is easier to do with 3 digits because it's more space. It's 432 times 1000 plus 2. 432 times 1000 just 432 with a bunch of zeros. And the other zeros are filled in by 432 times 2, which is 864. Just this part, the first part, and this part, the second part. It's all just 2 calculations, really easy. It's multiply by 1 and multiply by 2, really. I don't do anything more. I just know where to put my zeros. Right? So that's how powerful this is. You can make really complicated additions, multiplications really easy, just by using the distributive property. Right? Okay. Now we'll go to another example, very similar to the one in the video. Let's do like with an actual one, right? So three multiplications here. 23 times 19 plus 37 times 23 plus 47 times 23. You guys can. I would recommend maybe you guys get started on it as well, and then we'll discuss it together. So this is page 16 on last week's handout. And if you do on paper, you got a book, right?
No.
Think of a way to simplify this. So Ryan, we're doing this example here.
Yeah.
Give you guys a couple minutes to do this.
How much page was it?
16 on last week's handout. Don't just use long markers. Try to use the distributive property here to make it easy. Think what's a common factor for all 3 multiplications? And right, just put it on the chat when you finish, all right? Thank you. Problem is that there's 3 multiplication, right? What if you can bring it to 1 multiplication?
I'm done.
Very good, Ryan. Let me see. That's close, but not exactly, Ryan. It's a bit lower than that. Can I ask you guys what's the common factor here with all three numbers? 23. So maybe use that as a hint if you're not sure exactly what to do. And I know one of these and all of the other ones, 23 to the right, but in here, 23 to the left. Does that make a difference? So all the other ones, 23 is the number on the right, right? But here, the 23 is to the left on the first term. Right, it's not 19 times 23, it's 23 times 19. Does that make a difference, sir? No, right? Because commutative property can switch around whenever you want. Is it 58 plus 7? How'd you get?
Because I did 19 plus 37, 23 plus 47.
Was it, where'd you, so 27 to become? Was 19 the first one, 37 the second, 47.
Oh.
23 is the factor you take out, that's on the outside.
Oh.
So it is a bit tricky to get used to, but wait, I want you to do this. Do 23, you can take it out as a common factor. With the distributive property, you can like add the other three numbers separately. So what I mean is, take 23 outside, put in, put 23 outside. Maybe it'll be a bit more sense. And then what you do is you realize that you put in brackets multiplication and you put in brackets. Not that in brackets, but put the multiplication. Now put in brackets, right? And like open the brackets. Yeah, I'll show you. So, just here you go. You're going to get a simple. Very good. Do you know what to do this without a multiplication? Or we can reverse distribute from it the other way as well. Split it up. You know how I did the mental math trick? Just like that. Alright. So the idea here is that this is a common factor, distributive property. Look here. So we can, when you have something like this, we can go this way. Take the common factor out. So so that should be a times c plus b times c. I hope they're wrong. But when it's something like this, you can, when you have a times c plus b times c, what we can do is, or common factor c, I can take it out. Now I just add the other numbers together. Same thing with this problem. You have common factor of 23, you take it out. And then just add the other numbers together. There's 19 here, there's 37 here, there's 47. So just 19 plus 37 plus 47. Does that make sense how I did that?
No.
Because look, 23 is multiplied by 19 here, 20 is multiplied by 37 here, 20 is multiplied by 47 here. I'm just separating the putting separate multiplication into one. And once you do that, you just multiply one multiplication. What's 19 plus 37? 47. I think that's 19, 37, 47. 3 2, 3, 2, 3, 6, 10. 23 times 103, I think. And then here you can multiply with long multiplication, or you can do the distributive property again. You can split it. You split it in 23 times 100 plus 3. That's 23 times 2300. This part, and then you can do this one separately. Plus 23 times 3 is 69, I think. That's 2369. Does that make sense to you as well, Ryan?
Yeah.
Good. So I'll start with the hard one. There's an example. So we'll go with some easy ones first, then we'll build up to a few harder problems. All right. So yeah. So long multiplication, doing a lot of long multiplications will waste you a lot of time. Right. Whenever you can, try to shortcuts, because more you're comfortable like with multiplication, addition, stuff like that, the easier the next topics will be. Right. Okay. Let's do the exercise for now. So the level 2 exercises. Start with some easy ones. Start with A and B. I'll get you guys to do part A and B, and then we do as an exercise, and then we'll discuss afterwards. All right. So I'll give you guys about 5 minutes to do A and B. Yep. Go straight. By the way, Sarah, have you done this before? No? So I know some of you can probably do this without doing like just do them each individually. But even if you can do that, I want you to separate it up, use a distributive property. Right? Because 51 times 9, 51 times 31, they're not huge numbers. You can do long multiplication. But I want you to use the easy method. Not just about the answer, it's about how you get to the answer. So when we're using distributive property, you're going to look for the common factors. Right? What's a common factor? So you add the should we just take out the common factor? Don't have to. So how I did in the previous question. When I took out the common factor, I didn't add them together. I just took the 23 out immediately. I didn't. I just left it and I added the ones inside the bracket. See what difference between what you did and I did? So you took out the 51, but then you added it twice. You only added what's inside the bracket, which is 9 plus the 31. That's good. Then you also got to add you don't add the 51 together. The 51 says common factor. And we finish with that. Keep going with the next problem. Good.
I'm doing that.
Putting that. All right. Oh, sorry. I thought it was my bad. And if you're doing this, I've changed these slightly just to make it a bit harder. Good. sorry, you don't have to use a long multiplication there. It's 16 times 30. Because you can do 2 times 3. And you add a 0, right? So that's fine. You'd finally do it. But you should try to get the shortcuts because then later on it just becomes super easy if you just know the shortcuts. Right.
Did you see?
But we can't really do that one together. It is separately, but I think don't think this one's exactly right. But I would recommend it the other way. Take common factor out. Do you see the common factor between these two numbers? Is there any interesting number that repeats in the two multiplications?
See.
Just about recognize. This is about recognize first.
The guy is doing.
Okay.
And take away 16.
Not exactly.
Oh,
Yeah. So we're going to subtract again. Okay, that's a completely different approach. Right, you go with the other one. Keep going if you go. So how are you going to factor it out? So look how you keep everything. 51, and then you factorize the number, add the numbers inside the brackets. So what you did was you took out 51, you added the 9 plus 31, 40. Then you calculate that some number, but don't worry, not that important. So the same thing here. Take out the common factor, and you add the other numbers together. So think like this is like the rectangle here. Show you, this is like the picture. This is the picture I want you to think of. Like this is a rectangle with, so this is 51, and this is length is 9 here. This is another rectangle. They're not to scale, by the way. This is 51. This is 31. That's basically what you're doing. This is 51 times 31, right? You add them on by the area of the rectangle. This is 51 times 9. The idea is this rectangle, if you combine it together, it's the same as this one rectangle with, you combine these two together like here, what's going to be length now? This is still 51, right? I just combined them. If I combine like these two together, like combining in the middle, bring them together like this, then it's going to change to what? There's a 9 here from this length is 9 from here and 31 from here. You add the lengths together, end up with 9 plus 31. It's 40. It's basically what it's saying. 51 times 9 plus 51 times 31 is same as 51 times 9 plus 31. That's basically what you do in all these problems. You just that picture what we're doing with the other picture. And the same thing here, it's like another rectangle, this 16 by 24 rectangle, this 16 by 6 rectangle. And this one, and you're combining them into one rectangle for the part B. You just need to get it once. Once you get it once, it makes sense. And Ryan, how are you going with these problems?
pretty good.
Sorry? This probably is the one of the harder topics, concepts. It's weird at first, especially with these multiplications. But if you can get the picture in your mind, maybe it helps a little bit. Sorry, what did you say before science? Ryan, sorry?
I'm still doing them.
Still doing them? All right, that's fine. Does that make sense? Yeah, that's 100. Because once you start once it makes sense once, you can use it more and more. And that one is 34 times. Oh, sorry, first. Are you missing a 0 there, Ryan? Sorry, where's your 34. Is 34 common factor?
Because didn't you like change it?
I changed only one of them. 34.
Oh,
The first one's 34 times. The other ones are still 17. But are 34 and 17 related to each other?
yeah.
Maybe use that back.
So do I just divide it by 2?
Yeah, 34 same as 17 times 2. Right, I think C was really, really close. I think maybe you only take to 0. I think you got the idea though. That's very good. Keep in mind, this is probably one of the tricky concepts. Right? So if you're doing it well, that's really good. Keep going. Once you get used to it, though, it's fine. Just other side is where to keep your head around. You don't have to do long multiplication. This way you can distribute it properly. None of these problems you can do all of them without long multiplication. Yeah, I recommend don't do long multiplication for all of these. Try to figure out a way you can distribute it properly. It will make it so much easier. Think about common factors. So it's try to be out of your comfort zone, because once you get used to the new method, they'll become part of your toolkit and you can use them more and more. Later on, it'll just be easy. Is that 12? Is that 12?
Yeah.
But it's 34 times 12. Is that 17 times 12? Same thing.
Don't I have to times it by 2?
Not the whole thing, just, yeah.
Could I add the like 51 and 32 and like times it by the rest? Or
But once you get this one, you're going to add these two to this. Once you do all of them at the same time, take the 39 and you add the other numbers. You can distribute it with more than 2 numbers. So what you're saying, again, you want 32, right? We can also have the 17. Is part of all of these. Distribute, it's like a rectangle, that's 3 rectangles now. One of them is 13 times 17, one of them 13 times 51, another one 13 times 32. Just combine them all together. And the length of the rectangle is 17 plus 51 plus 32. See what he did here? You add that all the numbers that factored to 16. Then the same thing here, get 3 numbers. It's the same thing we expect extending 3 numbers. Think of rectangles. Try to be sure something. I would draw something small. split that to be easy. So what is it? What do you multiply the whole thing by 2?
Oh,
But you have to, only this first term is multiplied by 2. The other one, right? There's still 51 and 27. You should only multiply this term by 2.
just 12.
Yeah.
Oh,
Because it's 34 times 12, same as 70 times 2 times 12, which is 17 times 24. So I'll show you. Yeah.
Yeah.
34 times 12, same as 17 times, because 34 is 17 times 2. And you can just bring these together, 17 times 24. Now your number with all 17s is 24 plus 51 plus 27.
so we times 12 put 24.
Yeah.
Right.
See how you went, right? This. Oh, that's close, Ryan, but not exactly there. Think you didn't add enough numbers, maybe. What's the common factor in part D, Ryan? So it's a bit tricky. But actually, let's give the answer for this one. Check your answers for these ones first. First one is 51 times 9 plus 31 is 51. Take out the common factor of 51, which is like the length of one rectangle, and you add the other sides together, which is 9 plus 31. Oh, and 9 plus 31. I'm going to get rid of these pictures for now. But the idea behind is this picture with the rectangles. 51 times 9 plus 31 is 40, so 51 times 40. Same as doing 51 times 4, which is 204, and you get a 0 to it. Any questions? What I did? Right, and then here, same thing again. Common factor is 16. Take it out. Now let's put 24 here and 6 here. 24 plus 6. 16 times 30. Which is same as 16 times 3, which is 48, and you add a 0 to it.
Wait, I got a question for part D.
Part D, yep.
So when you're like timesing it, I got like 102 when I added it. So do I like take the 2 out?
Split it up again, just to distribute.
Yeah.
Yep. Exactly. And here, so multiple, especially this one's the tricky one. So it's weird to go from 2 to 3. All we're doing is using distributive property, but look, you find it doing with 2, right? For A and B. Makes sense for A and B. When you go to 3, it's the same thing. Just take out the common factor. What's the common factor here? 13. And if you take out 13 from here, what are you left with in this one?
17.
And same thing with other ones. The next one you're left with.
51.
If you take out 13 from here, and then you take out 13 from here, you're left with 32. Now it's one multiplication. Right? And then you add them together. What's 17 plus 51 plus 32? 100. So do it yourself as well. I know I'm giving you the answer, but keep doing it. If you haven't done it, please do it yourself as well. 17 plus 51 plus 32 is 100. 30 times 100, which is super easy. Just add a bunch of zeros. But it's just getting up to here. It's tricky ideas, right? We have some sort of pain, like bit of pain at the start. Just think about it for a bit. But once you think about it, you get rewarded with it because you don't have to do multiply by 100. You don't have to do all these really long, annoying long multiplications, right? And then same idea here. And if you're not confident with the concept, just do this one. But if you're pretty confident, replace the first term with 34 times 12. So I think just do this one normal. You're not confident yet, but if you are, do 34 times 12. They're the same answer in the end, right? And the way we do it, 34 times 12 just adds an extra step, which is you realize that these It's not common factor for all the three of them, right? Just by looking at immediately. But you realize it's 17 here and 17 here. Let's come through that. You don't have the 17 here, but what you have is 34, which is double 17. Right? And then you can factor out 34 times 12 into, because 34 is double 17, 17 times 2 times 12, which is 17 times 24. Once you do that, it's just 17 times 24 plus 17 times 51 plus 17 times 27. So all I did was change this up into this, and then I just brought the other two here. Right? And then all I got to do is take out a common factor, add. 17 times 24 plus 51 plus 27.
I got 102 for that.
If you're not, doesn't make sense, just keep going with the problems. So don't worry about this explanation. Just keep going with the problem if you've done this. Right? And I'll come if you need any help. But 102, right? You guys got. Did you do a long multiplication here, or
No,
what did you do here?
I split it up.
Very good. 7 times 102 is same as 100 plus 2. So you split it up into 17 times 100 plus 2. Then you get 17 times 100 is just add a zeros, double zeros. Plus 17 times 2 is just 34, right? Add them together, 1734. So that's the idea. This is probably the hardest concept we're gonna learn this chapter. Once you build on this, it'll be a bit easier. But it's just a lot going on. But it's just once you get used to it, it's not too bad. Right? We're just trying to get shortcuts of multiplication, right? Before I taught you this, you would have done all these problems. It would just taken you a long time doing all the multiplications. Now you have a shortcut. Right? So it's a hard shortcut to get used to. But once you get used to it, it's a really good shortcut. Right? Because what we're trying to do is, here's the thing. The reason I call it pre-algebra is trying to be comfortable in algebra. And if you get comfortable with arithmetic, we can focus on the important stuff, which is like the letters and stuff we learn in algebra. That's important. That's the reason we're doing this. All right? Okay. I'm going to leave E for now, but it's the same thing. You can split it up. It's distributed probably the other way. So don't learn those long multiplications E as well. All right? Okay. Before we move on, I'll just check up on, we'll have a 5-minute break now.
What's the time?
9:50. And we'll come back to distributive property later on when we do subtraction as well. Because we're going to apply the distributive property subtraction later. We just did addition now. We do subtraction later, and then we'll come back to, so hopefully you can revise your skills on that then as well. Johnny, have you watched the swimming championship thing?
Oh, not this week.
Oh, it's so sick.
I watched the footy today.
Watched your footy?
Yeah.
It was Carlton?
No.
What? Which one did you watch?
I watched the bonus.
Oh, you go for the Bombers?
Yeah.
Oh, nice. But sorry, you said you play basketball? You watch basketball as well or no? No, just play. Australia's like dominating all the swimming.
Yeah.
We'll start at 10, so a few more minutes still. Just want to watch the 200-meter freestyle.
Yeah, sure.
I really like that one. It's a bit,
How was your promotion thing?
it's about 2 minutes, so it shouldn't be too bad.
Well, I'm so proud of you, Dad.
200 metres freestyle. We've got the final about to unfold.
Let's start after this. There's no like Titmus, right? She was like a big favorite to win this.
Yeah.
Away in this final here with Titmus and McIntosh, the rivals in 4 and 5 there. Watch also for Hawhey in lane 2 and O'Callaghan in lane 3. This is going to be one heck of a race.
Yeah, McIntosh slow off the blocks. She just pulls up alongside him now. And Titmus edging ahead. We know Ariane Titmus, she loves to play catch me if you can, lead him out, trying to assert a little bit of dominance over the field. But there's plenty of back-end speed here. So Titmus turns first. That world record is under danger. She's 0.6 under that mark already, but there's a line of 4.
Yes, that world record has stood for a long, long time, since Rome, 2009. Pellegrini of Italy, 152.98. We'll be keeping our eyes on that. And at the moment, Ariane Titmus is under world.
Didn't play or something, because when like the Olympics were going on, like 2021, my teacher put that on and said play or something. Like he screened it to the
it looks fine on my iPad. It just when it comes to the TV, it's just the H. I think it's a lot of connections there. Maybe I'll show you guys at the end something. It's a bit better. Though you can't really see much from that because it's like,
blurry,
the frame rates are like you just like
exactly.
All right, we'll get started. We'll go to a new topic now, which is negation and the number line. And if you guys can, for homework, do this one as well. This is optional, by the way, but good practice. Yep. Part E. All right. We'll go to a new topic now, which is negation and the number line. All right, but before we do this, do you guys know what negative numbers are?
Yeah.
Oh, you've worked with negative numbers, It's just on the number line, the positive numbers are like the numbers we've seen before. We just extend the number line to the other side, go to negative numbers. It's basically what happened, right? You guys seen that before? Seen that picture? Yep. What about you, Ryan? You've seen negatives before, right?
Yeah.
Yeah, good. So we should, if we come to put negative numbers, this is good. So negation is a slightly different idea that we'll talk about a little bit now, right? So first of all, what is a number line, right? It's just a visualization of all of the numbers, right? All the numbers so far, at least. We have like 0, all the positive numbers on the right side of 0, and all of the negative numbers to the left of 0. So it's the yellow side here, right? So the number line splits the numbers into 3 parts. You have positive numbers, which is the blue here, and then the special number in between, which is 0, and the negative numbers, which are the yellow ones here, right? And it orders the numbers by scale or size, right? So the more to the right, the bigger the number. So for example, here, 5 is to the right of 3, let's say. Right? That means 5 is bigger than 3. Just like that. 1 is to the right of -4. That means 1 is bigger than -4. Same thing here, -2 is to the right of -4. -2 is bigger than -4. That's a bit weird because 2 is a smaller number than 4, but -2 is bigger than -4. It's just whichever more to the right is bigger, basically. Right? And also, the number value of 2, 3 or 4, whatever, you know what that means on the number line? Like if it's -2, 2, the 2 itself means it's 2 units away from 0. It's far distant to the 0. 0 is like a special number in the middle. And if it's like 7, it means it's 7 to the right of 7 to the right of 0, which is the origin. If it's -7, it's 7 to the left of the origin. So negative numbers means it's to the left of the origin. And if it's positive numbers, it's to the right of the origin. Right? So that's the key idea behind number line. You've probably seen that before though, so it should be fine. Right. Any questions about the number line though? No? Please let me know if you do, please. No? All right. Okay, so what is addition on the number line? So we have to add 2 plus -3. We know how to do that, obviously, we know it's 5. But how do you explain that on the number line? Let's say we start at 2. Let's start at 2 here. Start with 2 here. What does plus 3 means? We hop 3 to the right to get to 5. Probably seen that before, right? Okay, but what about adding a negative number on the number line? So we start at 7. 1, 2, 3, 4, 5, 6, 7. We start here. But addition is hopping to the right. But we're adding a negative number. So what are we doing here, basically?
We start from the negative number.
We could do that, yes, but let's just do it from just without, because we have 2 negatives. It's a bit hard to explain. How do I do this one? We have adding a negative. So think like this, right? I'll give you another perspective. You have 2 here and 3 here. 2 here, 3 here. Think 2 is 2 hops to the right of 0, and 3 is 3 hops to the right of 0. All we're doing is adding the number of hops. So 2 right, 3 right, that's 5 right. Think like this. Now here, we're having 7 is 7 hops to the right of 0. -4 is what? Hang on. -4 is here, right? Which is, what are the hops? You have to get a -4.
4.
Which way?
Left.
Left. So adding 7 hops to the right and 4 hops to the left. And if you add them 7 right, 4 hops to the left, so they'll cancel each other out, right? If you go like 7 forward, like the right, and 4 backwards, what are you going to end up with? Let's say you go 7 steps forward and 4 steps backwards. How many steps? Well, like how far? Let's say let's go. You say go 7 meters to that way. You come back 4 meters. How far have you gone? 3. So all we're doing is, we're adding the steps, but since it's to the left, we're adding 4 to the left. 1, 2, 3, 4. And up at 3. That's how we add negative numbers. That's the reason I say negative numbers. Because thing is, negative addition itself, just like addition is combining things together, right? So that only makes sense for collecting positive numbers. So we have to come up with a different definition when it's negative numbers. So we're just gonna this is something called generalizing. We define something originally just with positive numbers, but then we extend it to also negative numbers. So the way we do it is sort of reversing it. We're realizing negatives is the opposite of positive. So addition is going backwards now with the negatives. So adding the negatives is going backwards. It's basically subtraction. Right? We'll come back to subtraction later. But let's say we have a plus b. Here we have to create our own number because we don't know what a and b are. Let's assume they were positive. Right? So let's say a is here and let's say b is here. A plus b is, let's say this is a hops to come here, b hops to come here. A plus, actually, it means a different color. A hops to come here, b hops to come here. Sum would just be a plus b hops again. So this is b, a plus b here. I put a one big hop, but it's like little hops combined to that spot. So we can use this idea. We have more complicated questions. Well, before that, let's give you guys an exercise where I want you to obviously know the answer, but I want you to also visualize the addition on the number line. Right? So finding the answer should be pretty straightforward, but I also want you to visualize the addition on the number line. So show the hops, which is stuff you learned ages ago, but it's a good practice. Right? So the same thing I did here, basically. You're just doing the same question as I did. So you're just doing the hops, basically, and then telling me the answer at the end. But I also want you to draw the hops. You can just write on the handout, by the way, if you want. And I know it's a bit difficult for you, but just make a rough number line. You can do it on one number line if you want to. It's probably harder for you to draw 4. By the way, how'd you guys find the homework? Easy or difficult? Or
Some were easy, but some were like
some were hard?
50-50.
Okay. So yeah, the challenging ones spend a little bit longer. It might be hard, and I'll put a solution maybe. And if you have any questions after class, please let me know. You can spend a little bit of time going through them. All right. Okay. All right. So we'll discuss these now. So Ryan, how did you find these sort of 4 questions here?
So 1 plus 4 is 5.
Yeah.
And then for B,
you did the hops on the number line?
minus 3 plus 3 is equal to 2.
Yeah, that's it's correct. Not just the answer, but also
Minus 2, minus 2.
Yeah, but for part A, did you draw the steps on the number line? You start at 1, you add 4, go into 5. So I want you to not just get the answer, because the answer is really easy, but it's about showing the number line. Try to visualize on the number line, because then when we get to harder problems, you can also visualize. Right, there's a purpose to this task. As you'll see next later on, it'll help you with visualizing the harder problems. All right. So I want you to not just get the answer, but also show this working. Show the steps. So you start at -5, you add 3, which is -2. You go 1, 2, 3 to the right, which is absolutely correct. -2. But I also want you to show the working to get to -2. All right. And same thing here. You start at 3, so 0, 1, 2, 3. But then you go up by -6, which is the opposite. Instead of hopping to the right, you hop left by 6. So you go hop left by 6, you go 1, 2, 3, 4, 5, 6. You end up at -3. Right? And similar thing with D. You start at -2. And then which way do you hop now? Left, right? Because you're adding -3. Yeah. And then you go 1, 2, 3. End up with -5. So the answer is -5 here, -3 here, -2 here, and 5 here. But that's not the important point. The answers are pretty easy to get, but the important point is you being able to visualize. Because I'm going to give you this now. The next one, I'll give you with 3-digit numbers, right? And I don't want you to put 426 hops. That's ridiculous, right? You're not going to have to do that. But you can visualize the 426 hops. It's going right to 426, right? So we can think of either making it bigger or smaller numbers. So closer to 0, further away from 0. So we're doing like hard additions with negative numbers because normal addition, you've already figured out you can do long addition, whatever, right? But when doing hard addition that involves negative numbers, is where you got to start using the number line to help you maybe visualize. Right? Once you get used to it, maybe you don't do the number line anymore, but at the start, help you visualize the number line, right? So, can you guys do this one without the number line at -753 plus 426? You know how to do that? If I asked you part A here on the example. So we'll go through this together. There's a few more examples, so we'll go through this together as well. But you start off at, let's create our number line, 0 here. Start off at -753, let's say it's here. Right? And which way do we go from here? -753. Do we go to the right or to the left?
Oh,
What are we adding to -753? We're adding a positive number. Therefore, we go
what?
right. Because adding positive is right. Just like we visualize here, because whenever we added, even if you started negative, right? Like here, we started B, we started negative, but since we're adding 3, we go right. We're starting at -753, we're going right, right? But are we going to go beyond 0, or are we going to go beyond 0 like here, or are we going to go somewhere in between 0 and -753? In between, right? Because we're adding a smaller number. So that should help you with the scale, right? And then all we need to do is to figure out how far 426 takes us. We need to go 753. We can use subtraction of this. We need to go 753 to get to 0. I mean, and with 426 to go, how much are we missing to get to 0? If we go 426 to the right, I mean 753 total to go to 0. Remember, -753 means it's 753 to the left of 0. So to get to 0, we need to go right 753. The total distance 753, right? But how much more do we need to go to reach 0 from here? Once you go 426. So we go 426 to the right. How much more do we need to go to get to 0? In your subtraction numbers, right? 753 minus 426 should be our distance, which is a long subtraction. Minus 6 is 401, 13, 4. 30 minus 6 is 7. 5 becomes 4. 4 minus 2 is 2. And no, not for anything. 7 minus 4 is 3. 327. So we're missing 327. What does that tell us about our answer? Does it tell anything about our answer? At all, or do we just do it for no reason? it tells that our answer is 327 to the left of 0. And remember the definition of numbers? The value of the number is how far away it is from 0. If it's 327 to the left of 0, our answer is therefore. Because look, negative 753 is defined as being 753 units to the left of 0. That means the number that's 327 to the left of 0 must be. Just think for a second. This is it's going with definitions. Must be negative 327. To get why it's negative 327. Really tricky idea. Let's go back to where we started this. You know, when I explained how the value of, like, you know how it's like negative 4 and 4, what makes them similar, at the same distance apart from the origin. The value of the number is how far away it's from 0. So if a number is 4 to the left of 0, it's negative 4. If 4 to the right of 0, it's positive 4. Just like that, when the number is 327 to the left of 0, it's negative 327. If it's 327 to the right of 0, it must be. But anyone answer? Go say it if you. So I want you guys to get this concept. If a number is, let's say, okay, let's do another number. If a number is 380 to the right of 0, what does that mean? What's that number? Positive what the? If it's exact 380, the distance. Distance is the value. It's 380 then. It's positive 380. So if a number is 327 to the right of 0, the number is positive. Yeah, positive 327. If it's 327 to the left of 0, what's that value now? If it's 327 to the left of 0, just think, we're going left. Left by 1 is negative 1, left by 2 is negative 2, left by 3 is negative 3. Left by negative 327 is negative 327. So the distance is the number. And then the direction, if it's left is negative, if it's right is positive. So maybe let's write this down. Distance equals value, right? Distance from 0 equals value. So if it's 327 to the left or right, whatever direction, is the value of 327. We don't know if it's plus or minus. And direction equals sign. So if it's 327 to the left, it's negative. 327 to the right, it's positive. So if I'll ask you a quick quiz. So I'll do quickly here. Actually, I can't really write it down. I'll say it. If I give you a number that's 4,123 to the left of the origin or 0, what's the value? So 4123 to the left. To the left. Say it, it's fine. Anyone? Sarah? Not sure. Negative, and the value is? The number I said, I'll say it again, 4123.
Negative 4,123.
Yeah, so the distance is exactly the value. That's correct. And then because it's left, it's negative. So that's all it is. That's just what the number line is defined as. I want you to be comfortable with the number line. If it's so, we don't know what this number is, but we know that it's 327 to the left of the origin. Oh, 0, right? It's 0. Origin is 0, by the way. If it's 327 to the left of 0, it must be negative 327. So use that logic for these type of questions. So similar thing here. So it would be here. 787 plus negative 492. Right, we start at 787. Right? Then we go down. Since we're adding a negative, which way are we going? Left or right? Remember stuff we did from A, B, C, D? We add a negative. You go.
What?
Right means go more, right?
What?
Left, and why is that? Because negatives are to the left of the number line, so we're going in that direction. So we're going to the left by how much?
for that number.
Yeah, by 492. So if we go left by 492, there we go. So we're not going over the origin, right? We're not going to go all the way like this because the number's too small. The number's smaller than 787. So we're going to go like 492 this way. What's the value when you go 492 this way? You can think of the whole distance. Right? The whole distance is again what? You want to assist me? What's the whole distance between 787 and 0? What would that be, Ryan?
That would be
Because the number 787, remember? And you can use you can use this rule. Because the value is 787, the distance from 0 is also 787. Does that make sense, Ryan? It's a bit weird. I'll give you a shortcut later, but I just want you to get used to this weird idea first. Right, so I'm giving you the harder way, right? But the whole thing is 787. I just want you to be able to visualize that if a number is 787, it's 787 to the right of the origin. If a number is negative 787, it's 787 to the left of the origin. Right? And since we move 492 left, what's the gap here? What's left? What do we need to? What's missing here, I guess? What's this distance? The whole thing's 787, but this part's 492. This must be. How do we get this gap? How do you figure out? Let's call it x. I don't know what it is. How do you figure out what x is?
Like subtract.
787 minus 492. Yeah, very good, Emma. 295. That means our answer is a negative then? Because look, if it's negative to the left of the origin, is this number to the left or the right of the origin? This is our answer, right? This part is our answer. And the origin's here. So we're to the right. So it's still positive. So yeah, you're correct with the value. It's just because it's to the right, it's positive 295. So I'll give you a shortcut now, but the reason I made you go through all that is just that visualizing this is really important. We go to more and more. When you add negatives, it's the same as subtracting. Adding negative is the same as subtracting. 787 plus negative 492, 777 minus 492. So if you knew that, you could have done this straight away. Straight away, just easy, right? They just subtract immediately. There's the answer here. But it helps to visualize it because we have, because that doesn't help here. This is harder, right? So which way do you go when you add? Do you go 753 plus 426? If you do that, you're gonna get a 1000 something. This one lands on negative 327. So I want you to be able to tell which way are we going on the number line. If we start at negative, we're starting a negative number, which is actually I'll go, this is left, right? Start at negative 753, and 0 says 0 is here. Because we're adding a positive, we're going to the right, so we're coming closer and closer. We're stuck somewhere here. I just want you to be able to sort of see which way am I going on the number line. Or else I'll give you some problems to do on your own now. Okay? So you don't have to create your own number line, but at least you should know which way we're going, right? Because some people, the problem is you either add 47, like you go like, oh, negative 141 plus 47, or let's do 141 plus 47. Right? And then maybe put a negative sign at the end. That's not how it works. You got to know which way you're going. Right? So let's do this one. I'll help you guys out with figuring out what's going on. I'll give you a hint. When you're adding a negative here, same as subtracting. So you can be a bit lazy there. When you have, negatives plus negatives, it's a bit different, but anyway. that correct? Think of the number. I'm sure you will. You don't have to just. It's a good idea to just sketch a number and just see where it should be. Go down. So even if you don't like not sure which way to go, just think, am I going down or up in the value? Because negative 141 plus 47, am I going to increase the value or decrease the value? Like obviously it's bigger, like in terms of to the right, but is it going to be like a smaller value or a higher value when you add to a negative number? It's going to become smaller, right? You're going to get close to the origin. So you actually should be subtracting. Almost. Actually, give another way. I think it probably makes it maybe makes a bit more sense. You guys done addition and subtraction with negatives before? And how did you guys do it before?
I don't really remember.
Alright.
We usually took the number line.
Number line. Okay. All right. So, how about this? Instead of being so like find distance, that's a bit tricky. Let's say we start with negative 753 here, and you realize you need to. Which way do you go to? We'll forget about distance stuff, right? When we go plus 426, we're going to the right, right? So we're gonna go this way. We're gonna end up somewhere here and not like somewhere here, all the way to the other side because 426 is smaller, right? We're not gonna end up being positive. It's not big enough to go positive. But since we're going closer to the zero, we should be thinking we're making the number smaller in the value. So instead of doing negative 753 plus 426, we should be subtracting it instead of adding it to make the number smaller, right? So don't worry about the distance. Just be like, since we're making the number smaller, I'm going to subtract the value, right? And then you're going to figure out what that is. It's 2327, and you realize it's still to the left. Therefore, it's negative. So maybe that's one. So you just realize which way you're going. You're going closer to zero, it's subtraction. Further away from zero, it's addition. And then where you land, if it's to the left, it's negative. If it's to the right, it's positive. Maybe that's way different. Does that make sense? How you sort of break it apart? Does that make sense, William? If you get closer to zero, right? If you look here, if you get closer to zero, so we're going negative 753, we're going to go to the right by 426, right? We're getting closer to zero. So if you got it, you can keep going there. But sorry, Mal. When we go to the closer to zero, it's getting smaller in value. So the number itself is going to get smaller, even though we're adding. So we should subtract 426 from 753. And then that's not an answer though, because it's negative because it's still to the left. You do the subtraction, then you add the sign afterwards. All right, let's do these ones now. So does that make sense, Ryan? Hey, Ryan. Oh. Hey, Ryan. Sorry about that. I didn't realize you had dropped off the meeting. That's my bad.
Okay.
Yeah. So which part did you miss, by the way? When do you think cut out, I guess? If you keep going with these problems. Yeah. What did I say last when you got dropped out of the meeting? Hey, Ryan.
Yeah.
So, were you there when I talked about adding negatives and stuff? Hello?
You're a bit laggy.
Oh, okay. Can you hear? Okay. Maybe I'll see. Just let me know if I get laggy again, because I can't really do too much about it now. But so whenever if I'm unclear, please let me know. All right. So we're doing just these additions now, and I want you guys to use your number line as a guide to which way to go. So what I mean by that is, so I'll let you do part A, Ryan, and let me know what your answer is. Then I'll give you. We'll go through it after that. Positive or negative? Okay. Oh yeah, so I did that. So we're gonna put that. All right. Brian, have you done the first one?
Yeah, the answer is 94.
Positive or negative?
Negative.
Yeah, negative 94. Right, and I'll show you a way to visualize if you want, like maybe it's harder ones. It's just to see, start at negative 141, you're adding a 47, you're going to the right. That means you're making the number smaller, so you should subtract 47 from 141, you end up with 94. If it's to the left still, negative. Go to the left of the number line, it's 0. Left to 0, it's negative. So yeah, I think you get that, that's fine. All right, the first one is negative 94, that's good. And that's one other ones. Six, yep. And yeah, those two are correct. Okay, and what about B? What's the answer to B?
Me?
Yeah.
I got negative 500.
Is it negative? Yeah, value is correct actually. But it's a negative.
Yeah.
Okay, let's take a look at the number line, right? We start at 0. Okay, so we start at 887, which is here. Then go to the left, right? So we're adding a negative, we're going to the left by 352. About 352, is 352 bigger or smaller than 887? Small, right? Obviously. So we're not going to be able to go all the way around to the other side. We're still going to stay on this right side. So we're going to the left, so we're subtracting because we're making it smaller. But we don't go enough. By the way, if you can't see the TV, let me know. If you can't see, if the number is smaller, we don't go all the way around. So we still stay positive. Because we're going to the left, we're going to subtract, right? We're going to closer to 0. I'm subtracting. So it's 535. But it still says positive because it's to the right of 0.
Yeah.
So even though I added a negative, it's still positive. 535. And I'll give you a few drills for this. This important skill, recognizing which sign the final answer is. All right, and then to C, negative 2153 plus 1287 right? Who hasn't finished that, by the way? If you haven't finished it, we can give you more time. All right. What's the answer? So we got the answer. Ima? Yeah.
866.
Positive and negative?
Negative.
Yeah, good. It's negative 866. Right, and how do we get this? So where do we start off, Ima? Yeah.
I did. Like 2005. Minus.
Yeah, sorry. Oh, you need to go now? All right. Okay. Okay. Bye. And I'll upload the recording so you can see the rest. Right. So yeah, we start with 253. Subtract it. But why do you subtract? It's addition, right? Why do you subtract 127? You're correct. But
Because when it's us negative 2,153 plus 128.7, and even if you add it, it will still be negative. But
yeah. The idea is, if you think of the number line, right? You're going closer to 0. Yeah, that's why you're going to make it 4, right? Yeah, but you get that as idea, right? Fine, if you want to explain it, I think you get it. So you go 128.7, but you can close to 0, therefore it's getting smaller. It's a negative number. So it's this one minus 127. And then you get, when you subtract that, if you do long subtraction, it's 866. But then you got to check the sign. But if you look at your image, since you added a smaller number, it's still negative. Right? It's going to remain 866. This to the left is negative 866. Alright, very good. And then finally for D, right?
I didn't do D.
D. It seems hard. Let's just a subtraction in the end. Just gotta start off all the way up there in 11273, and then you go left by a smaller number, just 4979. So you're only gonna go around somewhere here. I don't know. Right? If you go here, we know our answer is going positive, but since we're making the number smaller, right? Because we're adding a negative, making it small to the left. Therefore, it's getting smaller. We do subtraction, right? 11273 minus 4979. You get the number from there. If it's positive, that's your answer. So I'll let you guys figure out what that answer is. But yeah, I'll let you guys figure that out. Johnny, what's the answer you got?
I got negative 6,287.
74. 94. Let's subtract here. 3 minus 1. 14 minus 4. 6 minus 7, go borrow 1 again. 16 minus 7.
Oh, no,
right?
sorry.
And then borrow 1 again. I'm just going to 111 minus 49, which is 62. It's 6294. Yeah, good. But is it positive or negative? Question.
I got negative.
Why is it positive? It's positive.
Yeah, but like at that time.
Yeah, but you get why it's positive, no?
Yeah.
Yeah, because we're not going far enough to go to the other side. Right? Does that make sense? That's all that matters. Does that make sense to you as well, Ryan?
Yeah.
Yeah. So because it's not big enough to make it negative, we just leave it here and 6294. All right. Let's do word problem. So let's do 1.3.3. Oh, sorry, guys. I should say to the right of -5, not 5. So can you guys do this one? So read through the question, understand what it's asking you. Do it. So I'll give you a hint is, you should be thinking of what are those numbers first before you figure out to add them together. What are all the numbers, negative numbers bigger than -5? To the right of -5. And what I mean, negative whole numbers, sorry. Not just like negative decimals, just negative whole numbers bigger than -5. So if you think of if you know which one they are, just draw the number and see which ones are the bigger numbers, the -5. Only a few of them. Number line now. So 0.
I'll go 15. Add those.
Yep,
So
right.
9 plus 3.
Careful.
Yeah.
Bigger than -5.
Oh,
Do we include -5 then? You correct if you excluded -5. So the numbers, negative numbers that are bigger than -5. This one, this one, and this one.
oh wait, so I don't add 5. Like,
Yeah.
Just leave that
Yeah.
out.
So you're correct other than that.
Yeah.
Does that make sense? It's just all the negative numbers that are bigger than -5 to the right of -5 are -4, -3, -2, -1. And to get the answer, just add those 4 together. And when you do, what do you get?
I got 10.
And I want you to check that answer as well. So do it yourself. See if you're going to get -10 as well.
I don't yet have like a whole negative numbers that are like bigger.
Okay, so it's okay. So this is a different version. I'd say to the right. Ignore the bigger then. Negative numbers that are to the right of -5. They're bigger as in they're closer. They're more to the right. That's all that I care about. So what are the negative numbers that are to the right of -5? It's just these ones, right? Because -4, so all other negative numbers are to the left. -6 onwards, they're to the left of -5. They're bigger like in their size, but they're to the left of -5. So only care about the numbers that are to the right. So I set in the brackets to the right of. So just to make it clear, because there is a bit of confusion there. But I'm just saying, what are the negative numbers to the right of -5? I'm just gonna go right. So from -5, start here. I go right. So -4, that's one of them. I go right one more. -3, that's good. I go right one more. -2, that's fine as well. It's still a negative number. Go right one more. -1. I go right one more. 0. It's not a negative number. So I only want these 4 numbers. And I just want to add these together. When you add those 4, what are you gonna get? Yeah, good. So it just ends up being -4 plus -3, -2 plus -1, which is just like going to the left more and more and more. So just adding all the numbers together. It's 1 plus 2 plus 3 plus 4, just 10, but negative. All right. Any questions with that? No? All right. Okay, now we're gonna come up with an idea called negation. It's really, really useful later on when we're gonna do subtraction and all that stuff. Right? So we know that when we add 0 to a number, right? Let's change that. If I do, 5 plus 0, the answer is going to stay as 5. Not going to change. But what number do we need to add to 0? Sorry, what number do we need to add to 5 to reach 0? We start at 5, we're going to add another number to reach 0. What do you need to do that?
-5.
Why is that?
Because if you have -5 plus 5, it's the same number, but it's negative.
In the opposite direction, right?
Yeah.
Yeah. So we start at 5. To get to 0, we got to go 5 left. And left means adding a negative. And just the amount we need to go left is 5. It's -5. So the number we need to add to reach 0 is the negative version, right? Which is the negation. We just call it negation. So the negation of 5 is -5. new idea called negation, right? The negation of a number x is the number we add to x to reach 0. So for example, the negation of 7 would be? Yeah. Okay. Well, let's talk about this. What's the point of negation when we have negative numbers? What's the difference, I guess? You guys, does it seem like just like we come up with a new idea when we already have negative numbers, right?
Maybe it's like is it like a reverse of numbers?
It is reverse, but why? But negative numbers are reverse of positive numbers. So why do you need negations when we have negative numbers already? There's a slight difference. Negation is not just negative numbers, it's just because it's broad, and here's why. Negative number is the negation of a positive number. But negation applies to negative numbers as well. So if I can ask you, what's the negation of -5? So negation can be positive if it's a negation of a negative number. Because the number I need to add to -5 to reach 0 is +5. That's +5. That's what the difference. You see the difference between negation and negative numbers? Because negation of a negative can exist and they become positive as well. All right? And what's the negation of 0? 0, right? Because adding 0 just 0 again. 0. So now that I introduced the idea of negations, can you guys figure out what the negation of the following numbers are? So use the definition. If you're not sure, what number do you need to add to that number to reach 0?
I don't understand like if like why is there like 3?
It means negation of a negation of a negation. And these same, it's a negation of a negation. It's 2 negatives, like double negation.
Oh, so basically.
Yeah.
Oh.
What's a negation of a negative number? So negative. So look at this. So negation. So we gotta figure out what this number is first with that only one on it, 2 negative, 1 or 0 negative signs, right? So you get rid of these negative numbers, negative signs. So we have -37 here. What's the negation of that? 37. So that's this number is equal to 37. What's the negation of this number then?
Could you just do like 15 and then like
15.
22?
But that is how is that gonna help though?
Wait, will it be like -37 because it's 2 negative, like 2 negatives, and then you take away 1?
You take 2 negatives and you take the negation of this one. 2 negatives is positive, right? 2 negation. Because remember we talked about it. Negation of -5 is like negative. Negation of -5 basically means -5 equal to 5. Just like that. -37 is equal to 37. But that's not our answer. This is equal to 37, right? -37. 2 negations, they cancel out, get 37. But what is the negation of this number? Yeah, that's the answer. Because what we did first is figure out what the number is by simplifying the negatives. But after you do that, you can figure out what the negation of that number is. Yeah, basically.
But like for f, if there's like three of them, do we just take away 1 so it'll be like negative 31 as the negation?
That's your answer?
Yeah, but negative.
Can you simplify that more? You can always, yep.
So FB 31.
Because let's figure out what this is first. You can do it your way, but just take away. You can. I think you should think of adding a negation, adding extra negative. So we're adding an extra negative to this. -31. There are 4 negatives now, right? And these 2 cancel out, so it becomes this 2 now. Sorry, only 2 now. And then these 2 cancel out again with positive. Or you can just figure out what this number is, right? There's 3 of them. 2 will cancel out with -31. The negation of that is also just 31. So both ways will give you the same answer. right? And you got negative, negative, which will cancel out to give you 30. So that's the same as that one. So how'd you go with this question, Ryan?
It was pretty hard.
Pretty hard. So the tricky point here is think of what number you need to add to reach 0. Right? For example, for 23, what do you need to add to reach 0? You want to cancel the 23 out. Start at 23 on the number line. You add some number to go back to 0. Like we talked about before, it's just the negative number 23, which is opposite of 23. So that'll be negative 23. Does that make sense, that one?
Yeah.
What about negation of negative 15? What do you need to add to negative 15 to reach 0? Start at negative 15 on the number line. Which way do you need to go to reach 0 again? Think of the number line. Which way do I need to go on the number line? So do I need to go to the left or to the right, Brian?
To the
Sorry, I didn't catch you there.
to the right.
Go to the right. That means you're adding a positive number, right? Therefore, you need to add what? You need to go 15 to the right. That means you need to add 15, right? If you go 15 to the right, you're going to add 16. The negation of a negative number is just the positive version of it, 15. Does that make sense? And what about the negation of 312? Which is the opposite, which would be?
Which would be
Just like a rule, right? The negation of positive number is negative, the negation of negative number is positive. So if you go from negative 312, you go to the other side, it's going to end up being. What's the opposite of 312? What's the negative version of 312, Ryan?
can you say that again?
What's like the opposite version of 312? What's the negation? What's like, if it's, look, the negation of 23 is negative 23. It's the negative version, basically. The negation of negative 15 is the opposite version, which is 15. So what's the negation of 312 going to be?
Negative 312.
If you add negative 312 to 312, it cancels out and they end up being 0. Same thing here. Here it's just 2 negative signs. So we have 2 negative signs. It's a negation twice. They cancel out to give you 37. Because like the negation of a negative 37 is negation of a negative is positive. They cancel out, right?
Yeah.
So 2 negatives cancel with positive. What's the negation of 37 would therefore be? What's the negation of a positive number? It's just the
Negative.
Yeah. So the negation of 37 would be
Negative 37.
Yep, exactly. And same thing here. Negation of negative 18 would be
Negative.
good. But what if it's already negative? So the opposite of that would be
Positive.
Yeah. So the negation would be 280. That's how we get to that. And a similar idea here, but we'll move on from that. All right. Negation, subtraction are slightly different, but we'll see how they're related later on. But we'll finish up with this. Negation and subtraction, they look the same, but they're different operations. What negation does, it takes a number and returns the opposite version. Like you start with 7, it gives you like negative 7. If you start with 20, negative 23, it gives you 23, the opposite version. But subtraction, you need 2 numbers and returns the difference between 2 numbers, right? So for example, we have 20, you can't just have subtract 23. You subtract 23 from something, you subtract 23 from 35. Right, when that happens, you just find the difference, which is 12. But we'll see how they're related later. But we'll start with, I'll give you some examples of where negations are really, really useful, right? So when we have additions like this, negative 20 plus 43, how do we do this? So let's think of the number line, right? So we'll go through this example, negative 20 plus 43. We'll go a bit over time. That's fine with you guys. All right. Yep. Do you have a question? Sorry? Oh, okay. You're fine with it. Okay, so we have starting at negative 20. So it's zeros here. We're going to go up by 43. We're going to the right by 43. Going all the way over. Because 43 is a bigger number, so we're going to the other side. So we're going to end up with a positive number. What do we do here, though? Yep.
I just did. I first took 20 from the 43, and then that brought me to 0.
Yeah.
And then with the rest, 23.
You just added the 23.
Which positive 23.
Yeah, perfect. Very good. And I explained this idea in terms of negations as well. Look at this. All you do is you break this, because this number is bigger, you can break the number down into 20 plus 23. Right? And remember, what's the negation of negative 20? Johnny?
Negative 20. 20.
Yeah, we have 20 here now. But broken down to negation and another number. Right? And if you add the negation with the normal number, what you're going to get? If I redo associative property, put the brackets around these, right? You can do this. What's going to happen if I add negative 20 and 20? Right, because they're negations. They cancel to 0. And I'll have to adjust this 23. 0 plus 23 is 23. Does that make sense how I did that, Ryan?
Yeah.
So I just broke it down to the negation. And then once you get the broke it down the negation, you can cancel things out and you can end up with this easy addition or something. Same thing here as well. We have the opposite now. We're adding a negative. 86 plus negative 152. How do we do this one? Yep.
I did 152 minus 86. Yeah.
Yeah.
And then
Yep.
I got.
Yeah. Good. So the idea here is this. Let's just do number line, because the number line is always good to visualize. Start at 86. 0 here, let's say. We're going left by, we're adding a negative, we're going left by 1. Too big, right? Just to, it's not, it's a negative number now. What we should do is break the 1, 2 down into 2 smaller numbers. Going left by 152, same as going left by 86, which is negative 86. We've also got to go another 66 to the left, which is the subtraction. Right? So again, this is a negation, these two cancel. You're left with negative 66. A different way to do what you did, but you got the same answer. We think of negations for breaking out the negations, cancel those out, you're left with another number. So we'll do one example now and we finish these 2 examples and we finish. And you guys do these using the same idea, A and B. And that's the last question for the day. By the way, did that example's part B make sense to you as well, Ryan?
Yes.
So it's the same thing, you just find the difference and sort of cancel things out nicely. You find the negations, but this matters.
Oh no, I'm just taking this as like reference.
For reference, oh, you're just thinking about it.
Reference, yeah.
Yeah, good. So Or another clever thing I saw from Mal was this is really good. Another way you can do this is if you don't want to sort of change, because the annoying thing about this is that this changes from positive to negative or negative to positive, right? For the A and B, the examples. We can do it if you rearrange it, because you can use commutative property, which ends up being 46 plus negative 237. Right? You can also rearrange this negative 253 plus 347. You just move them around. Commutative property we learned from ages ago. Once you move this around. Yep. So what are you saying, Ryan?
I understand now.
All right, you can do it this way as well. And then now you don't change the side. It'll just be in subtraction. So it's 249 for this one. And this one is negative 53 plus 347, which is negative 176.
Okay.
All right. Does that make sense?
Mm-hmm.
All right.
Yeah.
We'll finish up there. And if you guys have any questions, please let me know. Which one? Oh no, I really didn't get to it. If you want, I can keep. If you want me to take care of it,
Oh yeah.
or you can keep it if you want. Or do you want me to?
You can take it. So like I don't.
Yeah, right, sure. You want to keep that or homework? I didn't print it out, but I'll upload it online. Oh yeah, sure.
Do I have to get this one?
If you want, yeah. You can either submit in Google Classroom and give it to me.
The alchemist questions I didn't do because I didn't.
You haven't set up. Yeah, that's fine. The first 2 weeks, alchemist answers can be.
Yeah, so was my alchemist went really well.
Yeah, all right, that's fine. Brian, if you uploaded your homework, so that's good. You're finishing up now. Do you have any other questions?
No.
No? All right, we'll finish up there. I'll see you next week.
One question.
Right, bye.
Bye.
Stand.
Finish it up, man. Share, and I will call you.